And Grant,
shall I
let
begin?
you take it away, man. Yeah.
All right, appreciate it.
Nice round of applause, too. Couple more.
That only makes me more nervous. Hey all, I'm Grant. Originally in the Meetup thing, I think the title of this was Product Matters or something boring like that. Since I've been working on the structure of this, I've decided to call it Room to Grow for reasons I think will be more or less evident. But this is kind of my journey in building what's called a local first app, and the way that it helped me unblock a serious issue I had in building the app that I wanted to build, and let me kind of build the best stuff that I've built in my career that I'm really proud of. So I'm a Raleigh native. I've been here all my life. I've been working in web technology, especially React and TypeScript, for over a decade, and I love cooking. And I have this tiny little plant on my desk. This is like 10 times bigger than it actually is. That's not a large pot, y'all. So it's been here for 4 years, and this is the biggest it's ever been. For a while we thought it was dead, but it just kept growing. I kept watering it, and this is very inspiring to me. So I want to talk about a dream that I had a couple of years ago, more than a couple of years ago now. I wanted to make a cool cooking app because I like cooking, and I wasn't really satisfied with the kind of stuff that was available to me. So I tried and I failed because I used all of these cool tools. I got into Google Cloud's startup program. I got $3,000 for free, which is amazing, and I spent it. And so at the end of the day, I was left with an okay cooking app that cost a lot of money a month to run. So the model that I was following was what I understand is kind of like the startup model. And the idea of that model is that you go and you get venture funding off of your initial implementation, and then you get $2 million, and then you can keep paying that bill. But I was building a cooking app, so nobody's funding that. So I had to give up on this idea because I didn't have the time or the space to let it grow on its own. So I want to talk a little bit about how we build apps, especially how we build web apps. I'm a web developer, so a lot of this is going to be focused on that domain. And you probably already know this, right? So we have a client, and the client asks the server for the world, right? It asks for the truth of the state of the application, and it gets that. So then the client starts making some changes, and it sends those changes to the server, and the server responds to that by computing the new state of the world. And then the server sends that state back to the client, and now the client knows, okay, my changes were made, and now they're true. They're in the world. They're in the state. So there's some interesting and frustrating things that come out of this pattern. And since it's such a common default pattern, it's easy to think that these are unavoidable problems. So the one that I'm very familiar with as a web developer is validation is just a huge pain. Because you want to validate on the client so that the user gets instant feedback. Okay, I didn't do that right. I'm not going to be able to submit that. It's not going to save. But then you also want to validate on the server, because if you only validate on the client, then people can just submit bad stuff bypassing your client entirely, and it's not secure. Those validation rules have to be aligned in order for your app to work predictably. And your server may not be in the same language as your client. If it's not JavaScript, it's not going to be. So you end up having to write the same validation stuff twice, which is kind of a pain, and keeping it in sync is even more of a pain. Another tricky problem that you'll get into if you're building a particularly robust client is, let's say you're building like a whiteboard or a spatial canvas, something where you move on the client, you move one object from one place to another. Well, that move that you made, if you send that to the server, you're going to have latency before it can tell you the final state of the world that it computed from your change. So that latency, if you do this naively, you move the thing, and then immediately it moves back to where it was. Well, it waits for the server to tell it what to do, and then when the server responds with the new state of the world, it moves back to where you moved it. So you can't have that. So we cache it locally. We basically have a caching problem where the client has its own copy of the truth. It makes local changes instantly, and then it waits for the server. When the server responds with the new state, it tries to figure out where it's supposed to be now. It does cache and validation. If you've worked with something like Apollo client, maybe you've dealt with this. So it's kind of a pain. It's a little difficult to explain just why it's a pain, but if you've felt it, you've felt it. And then, of course, a new client joins. It gets the state from the server. It's not aware of anything that happened in the past. It just knows what the world is right now. That can also be kind of a disadvantage. So that's kind of like more or less a brief overview of how we build web apps today. So here's how we build local first apps. And I'll try to define this a little bit more precisely later on, but I want to demonstrate what it looks like first. So in a local first app, the source of truth for the application state is all on the client. So the client has its own database, and that database is authoritative. It doesn't have to ask the server what the state of the world is. The client makes a change, and it applies it to its local data. If this is sounding like normal software, it is. So in order to synchronize that client with a server so that it can, let's say you're on your laptop and your phone on the same app, and you want both the data to be the same on both of those devices, you might want a server to synchronize them. You send the change to the server, and that's it. The server doesn't actually know much about your app. It just stores change sets. Okay, so another client comes along. Let's say you've connected your phone where your laptop was already connected. But this client hasn't gone online yet. It hasn't talked to the server yet. So this client will make a new change that's different from the original one. They both started in the same place, but this one ends up at C, whereas the other client ended up at B. So now we have a bit of a problem. We have two clients that are presumably talking about the same app, the same data set, but they've made divergent changes. So when the second client starts syncing to the server, it syncs its changes up to the server as well, and now the server has the full view history. And then the server propagates those changes out to both clients. And basically what happens here is because the changes are stacked on each other in history, and they're deterministic changes, they're atomic changes, you go from A to B, B to C, and as long as both of them all get the same change sets, they converge on the same state. So I'm rushing through this kind of quickly. You're welcome to ask me questions about it later on. This is a topic we call CRDTs, which is a very complex field of study that's still evolving. But the gist of it is you can have clients that are offline. They maintain their own copies of the database. They can make changes to those things. When they synchronize, in the end, they're going to end up in the same state. This is a very similar thing to what like a database cluster does behind the scenes. So interesting properties that come out of this is that you only have to write validation once. The client is the only thing that has to validate the changes. The server doesn't even know what your app really does. The server is just a storage and synchronization for these change sets that are being passed around. So that's convenient. And another cool thing about this is that each client is a self-sufficient application. The world starts on the client. It doesn't have to ask the server what the world looks like before it can go ahead and start doing things. So these properties were really nice for me as I was looking at building my groceries app a second time. So I'm going to try to summarize more or less the principles as I see them of what local first is. Different people have different definitions of this. But the idea is the data lives on the user's device. So on your phone, there's a database. On your laptop, there's a database. That's what your app interacts with. The app works offline because of that. And on the web, you can do that with something called PWAs, where you actually cache the HTML and the JavaScript and the other assets on the user's device. So even if they don't have network connection, they can still load up your web app. The data can be replicated to other devices. That's the CRDTs I was talking about. Eventually, when you sync up, all those devices are going to see the same thing in all of their local databases. And that means you can collaborate with other devices and you can collaborate with other people on the same app. And there's other nice stuff that usually gets added in here. And it's not even on purpose. It's just that these things are really easy to implement in this model. One of them is undo and redo. So because all of those changes are stored as changes and not as state, all you have to do to undo something is make a reversible change. So if you define reverses for all of the changes you made, apply one of those reverses and you've undone the change. Live multiplayer editing is another big thing. So think like Figma or Google Docs. All those cool like simultaneous edits that you can do in those apps are actually very easy with this model. And the reason for that is because, I've sort of been talking about this as if, you send a request to the server with your changes and you receive a response with other changes. If you just make this a WebSocket, because the protocol is able to synchronize without conflicts, you can make these changes as fast as you want. You can propagate them to other devices as fast as you want, and you end up with a consistent state. And that is basically what powers tools like Figma. So I made a local first framework. It's called Verdant. It is what I call a framework and a philosophy for small, sustainable human web apps. It's very pretentious. But the thing that I got really inspired when I was building this because it was helping me to build the kind of apps I wanted to build sustainably. So, my original idea failed because I couldn't keep paying for it. And I was not going to go the venture capital route, so, what was I left with? In this situation, because the apps are standalone, they don't require a server to work, people can use my app standalone for free, and then I can sort of incentivize them to sign up for things like sync and multiplayer collaboration. And that actually pays for the servers that it runs on. This is a sustainable model of software that I found to be very rewarding. I think maybe it'll be easiest just to kind of demonstrate what it looks like to build with these tools. So I'm just going to go ahead and jump into my demo here. All right, so I have a CLI that I made. Is this big enough, you'll think? I'll make it a little bigger. So I've got a CLI to bootstrap an app, and I'm going to go ahead and run that. And it's downloading. I didn't think about, okay, the network here is good enough for that. Cool. So I'm going to go ahead and build what's called a local only template. So this is building just a static website with local first data. I'm going to call this demo. And demo, cool. All right, it's going to install the dependencies. So yeah, the idea here is this app that I'm building, I can actually bundle as static HTML, JavaScript. I can put it up on Vercel or AWS S3 or wherever I want to put it. Anyone can go and visit that domain name, pull down my app and use it. And as Brandon kind of alluded to, I don't have to really have a server in order to make a usable app here. So I'm going to open this in VS Code. I'm going to close this old version. Okay, and the first thing I'm going to open up is schema. So every Verdant app has a schema, or schema if you like. And the schema defines all of the data that the app can interact with. And so in this case, I have scaffolded a basic to-do app, which I'm going to stick with because it's easier that way. And so it's got a collection of items. So this is a document database. Don't hate me. It's easier with documents in this kind of situation. SQL, like relational databases, are very hard to replicate in the way that I'm trying to do here. So documents was just where I started. And it's got fields. So I've got an ID field. I've got a content field, a done field, and a created at. Kind of the basic stuff you'd want for a to-do item. And then I also got indexes. I'm using the browser, the database that's built into the browser called IndexedDB, which requires you to define some indexes in order to query from. So that's what I've done here. Because my schema is a TypeScript file, I've tried to build out some nice to haves here, like it's validated against the fields that you've created. So I'll create an index on the created at field so I can query documents by when they were created. And I'm happy with that schema, so I'm going to go ahead and publish it. So I run pm generate. Oh, I need to cd into demo first. Cool. And I'm going to publish a final schema for this. So this is going to generate a client with all of the typings based on my schema. If you've used a tool like Prisma for database access, very similar principle that I basically just copied from them. And now let's open up. So I'm going to open up the actual app portion that interacts with this data. So this is a React application. And like I said, it's scaffolded a basic to-do list. So I will go ahead and just go through that code. So it generates some React hooks for me. They're all named and typed based on my data. So here I'm querying all of the items in my database, and I'm using that index I created so I can order them by when they were created in descending order. This should return all the items the most recently created first. And then I map over the items, and sorry if you're not familiar with React code. I will show the actual app in a second. So I've created a component to render the items. So each object in Verdant is reactive, and so this hook subscribes to changes on the object. So this component will re-render when the item changes, and it also lets me use the content inside that item. So I've got typed data for the item itself. The fields that I defined in the schema are here. I've got done, which is a Boolean. I've got content, which is a string. I'll pass done to the checked attribute on my checkbox, and I'll listen for changes to the checkbox and set done to the new value. So pretty standard setting of a Boolean there. And then the item will have content from the data as well. And then there's the add to do. Of course, you need a way to create new items. So this is just a basic form, and it creates to do items from that. Like I said, I'm a big TypeScript fan, so all of these are fully typed. Content only accepts a string, it doesn't accept a number. This is important for local first apps particularly. When the data lives on the user's device, any corruption of that data is very difficult to recover from, since you can't go and grab their phone and debug it. So this is probably the scariest thing about local first for me, which is why I went so heavy on TypeScript. I went with a validating schema and all of the other junk around that, just to make sure that nothing particularly bad happens in production. And even then, honestly, some things have, and I've had to recover from them. But that said, I've got a functional app here, so I'm going to go ahead and start it up. Okay, and I'm on localhost. And here we are. So I can make an item 1 or an item 2. As you can see, like I said, they're coming in reverse created order, so that index is properly querying. And I can check, etc. The big thing in here is that I can reload the page and my data is still there. So from 0 to this app is what I've done kind of on stage here so far. And like I said, I could deploy this app as a static web page anywhere for free, or close to free, the cost of a domain name. And it's now functional. I could use this on my phone or whatever, but it won't sync to my devices yet, so I should probably fix that. So I'm going to go ahead and run a sync server. This is a toy demo server, but the real one isn't too hard to spin up. And this is going to give me an endpoint that I can use to synchronize. So I'm going to go ahead and open up my client configuration. I'll delete a few extraneous things. And I'm going to create a sync section here. I'm going to pass in the auth endpoint that my server gave me. And I need to do a few other things that I should probably fix. It's scary when a demo is all code that you wrote. It means I'm completely responsible for all of this. So don't worry too much about this stuff. It's stuff that you have to do, and it makes more sense if you're actually building a real app. One thing I am going to do is create a stable user ID, just so that I can identify myself to the server with each client, and if I reload the page, it's going to have the same ID. It's going to treat me as the same person. And I'm going to fill that into my thing here. Give it a library ID. A library ID is basically a room that I'm connecting to, so I'm connecting to the demo room. And that's not quite it. I need auto start. So now it'll start synchronizing as soon as I reload the page. And of course, nothing changes because synchronization isn't a visible thing. But I will open up another profile here. Put them side by side. And it's the same data now across 2 different browsers. So these are entirely isolated from one another, but they've synchronized across my server. Another thing, of course, is real-time multiplayer that I just got out of that. So item 3, ta-da, pretty neat. So again, like I just want to emphasize, this is all I really added besides connecting to my server itself. And what I love about this is I didn't have to change any of my client logic to accommodate a real-time multiplayer situation or even an online syncing situation. That's just one of the ways that Local First kind of slices the problem of having an app that talks to the internet in just such a way that you write the same code for completely offline or completely like online real-time, and you don't really have to worry about the difference between the two, which I think is really fun. So let's go from there. Let's add something more interesting, since I think I have a little bit of, well, I don't know, I'm running up close. Let's see how quickly I can add file uploads here. So I'm going to add a schema.fields.file. I'm going to make nullable true. This means that it's not a breaking change in my schema. If I add a new field to my schema, but it has a default or a nullable value, then Verdant can just automatically upgrade all of my clients as soon as they come back online with the new data. So let's run pm generate again. I'm still not in the right folder. All right, here we go. I'm going to publish version 2. We do have migrations in Verdant. Like I said, I don't need one for this one, but it does let you do them. So this is where if you dramatically change the shape of your data, you would have to go massage it all into the right shape again. And all of these run individual on every client. So it's a distributed system. It's really fun to work with. It doesn't scare me at all. So yeah, that should be online and running now. Of course, I didn't change the actual UI, so let's do that. All right, so I've added a file attachment to every item. So let's go ahead and input type file. And I'll accept only images. Let's open up an on change here. So Copilot's helping me out here. That's nice. Basically, I'm going to pull the file out of that file input, and I'm going to set it as the attachment on my item. That's all I need to do to upload files. But first, I also want to be able to display them. So when I ran generate again, my typings were updated. It now knows about attachment as part of my item. But I do have to use watch on that. It's a little awkward. It's not as syntactically sugary as something like solid or svelte's reactive data, but it works. It's good, honest work. And then if I have an attachment URL, which means if my file has been successfully uploaded, I'm going to show an image with that attachment URL. And I'm going to go ahead and give it a width of 200 so it doesn't get too large on screen. Okay, so as you can see, UI updated. I now have file inputs on all those items. I'm going to grab a picture of my cat. And it's synchronized between both browsers almost instantaneously. So yeah, that was all I need to do file upload. You can configure file uploads to be in S3. Right now, they're just on a local folder in my laptop. File uploads also work offline, so they're not technically uploaded. They're stored on your device, and then they're uploaded to the server as soon as the server becomes available. I'm going to skip, well, I feel like Brandon, you gave a little bit of a lightning talk at the beginning there, so I'm going to give myself a tiny bit more time to show offline capability. And this is the part that could screw up, so bear with me. Oh my gosh. This is not the part I expected to struggle on in the demo. It's clicking a menu. All right, so let's go offline on this side. And let me double check to see if that worked. It did not. Okay. This happened in my original practice for this. WebSocket connections don't always terminate when you go offline, just in the dev tools, so I'm going to try to sneak this in here. All right, really offline. Okay, so now this side is disconnected. It's not synchronizing anymore. But it can still use the app, which is cool. So if you're on a subway or in an airplane, or the server itself has crashed, which scares me when I'm building traditional apps. I don't want to get called in the middle of the night because the server is down. You might not even notice with this because I can keep using the app just like I normally would, completely offline. Meanwhile, this guy can continue syncing its own items and using it in that way. When I go back online here, everything syncs up and we're all in the same state.
I'm curious, are you able to shut down the server and see what happens?
I could, yeah. Oh, I think I just accidentally did. No. I misclicked. I shut down something. Let me get back to... Pretty sure I shut down the dev server. Yeah, here we go. All right, so now these are well and truly offline. There is no server running. You can continue, like I said, you can upload files. They just get stored on the device. This helps me sleep better at night with my little groceries app because I know that my 1 or 2 paying customers may not notice if I'm on vacation for a little while and the server goes down for a couple hours. I will try to fix it as quickly as possible, but I'm not really under the gun, which I love that. I don't know about you. So that's the extent of my demo. I'll jump back here. So there's a few more things I want to say. One is that I did make my grocery app, and I'm really happy about it. So the way that I've structured this app, like I said, it's a static web page which anyone can go to for free and start using. Almost every feature is available for free users, and those free users cost me nothing besides the domain name, like I said, which is great. So I can post it on Reddit, and if it blows up, and that's awesome. I don't have to worry about that. If people start signing up, they're paying me money. So if I need to upgrade the server, I will. I'll have the money to do that. And this is, I think, a really cool way to build small apps like this. But there is one thing I'll say about this is that this is an application of what I would call leverage. Local first works really well for certain classes of problems in the same way that certain tools work well for certain classes of problems. And the thing that I learned a lot when I built this and when I figured out about local first and what it could do for me, goodness, is thinking about tools like software tools the same way we think about real tools. If you want to pull a nail out of a board that's stuck, you probably can't do that with your hand. You could maybe devise a really cool machine that will do the same motion but more powerfully. Maybe you give it a really good motor and a nice gear ratio to get a lot of torque on there. And there are certain use cases where this machine is a good solution. Maybe you've got a very narrow space that you need to pull vertically, like it's a very particular problem. But I think we know the real solution to this problem that works in most use cases is the simple, affordable, easy-to-use hammer. Because it applies leverage appropriately for the problem, it can be much simpler, it's easier to maintain, it's cheaper to build. And that is kind of the principle that I want to convey about building software. If we change the way that we approach the solution, we may get a much, much simpler and more economical and more sustainable approach to our problem. And that doesn't have to be local first. Just think about that in any application of when you're building software. So that plant is still growing, and my app is still growing. I said I had a few paid users. These are them. Do note the y-axis scale. We're in the single digits. But what I love about this chart is that, one, like I said, I don't have to worry about this. It is the paid users pay for their own server time. The free users cost no server time. And another thing is this represents a profit, which is more than a lot of venture capital funded startups, I think, can say. So it's growing and it continues to grow. I'm getting more users, but I don't have to rush it. I can go at my own pace. I have a 1-year-old son. I can put this aside for months at a time just to be with my family, come back to it. It still works. It's still working for me. and I haven't lost anything. I don't have to shut it down when I run out of money. That's all very exciting to me. I don't know if it is to you, but thank you for listening anyway. You can find me at g4.rest. You can find Verdant at verdant.dev if you want to play around with it. Of course, my groceries app is at noki.club. And that's my cat. Thanks.